Hey, how's it going? So we've looked at a couple of functions, three functions actually, max, min, and pal, and you've worked on recreating these functions. So max gives you the bigger of the two numbers. If you give it two numbers, it's called max. It's the maximum. Minimum gives you the smaller of the two arguments that you give it. And then pal takes the first argument, so in this case maybe 7, and raises it to the power of the second argument. So 7 to the power of 2, that would be 49. 7 times 7. Now we're going to spend a little bit of time here working on an additional two functions within Python that you can use at any time. Now, you do have to know how to use them, obviously. So let me talk about the first one. The first one is the absolute function, abs, which basically takes in one argument and gives you its absolute value. Recall from math, the absolute value is really the distance that a number is from zero on a number line, without caring so much about a negative, the negative direction to the left or positive to the right. So it just gives you a positive number always, whether you give it a positive number or a negative number. The absolute value of something is basically what its value is without regards to the sign. So it's actually pretty straightforward in terms of what it does. Now you're going to have to think about how to implement one of your own. So you're going to create an absolute function. And then the other function is a little more involved. So I'm going to spend some time talking about it, but it's the round. The round, say you round 5.6. It gives you 6. It rounded up to the bigger whole number. It did round up, and it rounded up because of the 0.6. Okay? But if you give round two arguments, so like 67.83, and then you give it the number 1. Now, this second argument is basically how many numbers do you want after the decimal? So 1. So it would keep just one number after the decimal. And so that would be 67.8. However, if I do 67.85 or bigger, 85 is still 67.8. Let me do 86. Notice how it does round up. So it rounds up for, it checks the number after the first digit here, after the decimal. It looks at this number. If it's 6 or bigger, it's going to round up to 67.9. So if I instead make this slightly longer, so like that, and I say I want to keep 3 numbers after the decimal, would be 67.863. Where to determine whether you're going to round the 3 up or not, you basically take a look at the following number, and if that following number is a number that's 6 or bigger, you round the 3 up to a 4. Excuse me, you round this 3 up to a 4. So the round function, again, a little more involved. Okay, so that is important that we understand that its functionality is just a little more complex than the absolute value function. One thing here is that when you don't give it an argument, that just basically rounds to the nearest whole number. But when you do give it an argument, a second argument, well, that's what I meant. So when you only give it one argument, it rounds to the nearest whole number. When you give it two arguments, so which would be the number itself that you want to round, and then the place value that you want to round to. So in this case, 1 would mean one number after the decimal. 3, keep 3 numbers after the decimal. Then it rounds accordingly. Also, once again, note that it does round up when necessary, okay? Just like it did here. It rounded 5.6 to 6. So very important things to note. I'm going to spend some time talking about this specific functionality. This one not so much, because I think this is pretty doable. What I want you to do is first define a main function like what I have here, execute what's in the main function, and within the main function we're going to place two calls, one to apps. Notice that I use all caps because if I do lowercase, it's going to think that I'm trying to use the built-in Python function. I don't want you to do that. I want you to define the apps function up here. Now apps right here is going to return something. I'll put here just A for now. You do need one argument for the absolute value function, which means that you need to create one parameter here, A. So one parameter, and right now I have it returning A, but this needs to change, obviously, okay? So you're not always going to return A. Now, when I call the absolute value function from the main function, I'm going to store what it returns in a variable called just value, something like that. Value equals abs. If I send abs -67, it should return to me a positive 67. So value should be positive 67. And then I want to print that value. Which means that if you coded this correctly, the abs function, then when you execute this print statement on line 10, it will print 67 because you're sending -67 as an argument, which is going to be stored in A. You're going to write some code here that you need, and then you're going to return a positive 67 that will be stored in value. Remember, value equals what abs returns when I send it a -67. Round. So I'll say here rounded equals round, all caps again, because we want to make sure we don't confuse. We don't actually call the built-in round function. If you do all lowercase, it will change color on you, and it will use the built-in Python function. That's not what I want you to do. Round, like that. Now, there are two implementations for round. Round with one parameter. I'm putting return A as a placeholder, but you need to think about what you're going to return. And then there's also going to be a second function that's also round. So notice that they have the same name, but this one will take two parameters. And I'll just return A once again, just for now. So rounded, when I give it only one parameter, so something like 5.6, it will round to the nearest whole number. So rounded should be equal to 6. When you round 5.6 and you don't give it a second argument, then it just rounds it to the nearest whole number. And rounded, I'll just call it roundx. If you execute the round function, that actually requires two parameters. So where you do 67.8 63, comma 6345, comma 3. Roundx should return 67.863 because you're rounding the first argument by keeping three numbers after the decimal. That's what this means. And then you would once again print rounded. This should give you print 6 and print round x, and this should print 67.863. So that's the job here. The fact that we have two methods, I say methods and functions. The fact that we have two functions that go by the same name won't be a problem if you have a different number of parameters like you do here. On this, on the first round function, you only have one parameter. However, in the second round function, you have two parameters. This is called overloading in programming, which is when you create two functions by the same name with a slight difference. We're overloading. Now, let me just run this to ensure that there's no issues. Hmm. Clearly, there are issues. So the overloading is not quite working out for me. Notice that when it executed round here, 5.6, it was thinking I'm going to execute this code, which requires two arguments because there are two parameters and I'm only giving it one argument. So overloading is not working here. And I need to take a look at why that's not the case. There's always a way to pause this. And for some reason, sometimes it just doesn't show up. And so now you're stuck here. Okay, I'm gonna look it up while you're here. You can kind of fast forward through this piece if you want. Python does not support overloading functions. When we define multiple functions with the same name, the later one always overwrites the prior, and thus in the namespace there will always be a single entry against each function name. So that does it. Okay. So creating the function round on line 6 is then overridden by the function round in line 10. So this is overridden. It's like you delete it basically. And so that's why when I try to send one parameter, then it has an issue because this was deleted. So there's only this round function that requires two arguments that are going to be stored in parameters A and B, which is okay. Okay. What we're going to do is that we're just going to delete this. And your round function is going to work such that if you give it a 0, it should round the number to the nearest whole number, which might be true if I use round. 5.6, notice this rounds to a 6, and if I put a 0 here, well, it rounds to 6.0. So it gives you a numeric, a decimal value rather than an integer. So there's a key difference, but it's okay. So right here, you're going to create two methods, round and absolute. Now let me talk about how you could round this, because that's important. I want to try to give you as much help as I can here with this without giving it away. So let me show you how I think about rounding this. Say I have 67, I'm going to write it down, 67.86345. And I want to round to 3 decimal places after the decimal, 2 places after the decimal. That means I want this right here, the 863, just that. And what I can do is multiply by, there's 3 digits, so multiply by a 1 with 3 zeros. And now that gives me 67,863. And then if I take that 67,863 and I make it an integer, .45. It gets rid of anything after the decimal. So that's gone. The 0.45 is gone, which is convenient because that's what we want. What would I do to this then to make it 67.863? Well, I would divide 67,863. I would divide it again by 1,000. And now it's kind of been rounded. So the process then is take the first argument, this argument, multiply it by a multiple of 10 that has the number of zeros, in this case 3 zeros, given by the second argument. And then make it an integer. so that you can truncate any trailing decimal places, and anything after the decimal that gets truncated, it's erased. And then once again, where you had multiplied by 1,000, now you're going to divide this new number by 1,000, and it gives you the desired outcome. Now, if you do have to round up, there's an extra step, right? So let's say, for example, that I have the number 89.567, and I want to keep two numbers after the decimal. That means I would want to keep 5 and 6, but the 6 needs to be rounded to a 7 because the next number is bigger than 5. So what I want to produce is the number 89.57. That means I need to round. So how would that look here? It would look like this. If I executed my round function, I would send it 89.567, comma 2. That means keep two numbers after the decimal. And so the process that I've mentioned here is this tells you how many zeros you're going to put after the 1 when you multiply. So I would multiply this times 100, so times 100. And notice that gives me 89.56. Now, because here, if I make it an integer like I did up here, it will get rid of all this, but I want that to be a 7. So how do I do that? How do I ensure that that happens? Well, you're going to say that if this is greater than 1, greater than 5, then you want to add 1. So it's a little tricky here. You do have to use an if statement. After dividing by 100, I want to identify whether the number after the decimal, is bigger than 0.5. So I would do something like maybe, well, I'm going to leave it up to you, but you need to add 1 here, using the fact that this is bigger than 0.5. How do we get this right here at the end? Well, you can always use the modulus operator. You can take this number. So I'm going to actually store this in a variable right now. Call it num. Now I have num in there. I'm going to say num. If I get the remainder of my number, when I divide it by not so much itself, but not its integer self. So if I get the remainder of num by 89.56, it gives me 0.69, which is basically saying get the remainder of when I take num into num, and if this value is bigger than 0.5, so we would do an if this number, which you should store in a variable, call it remainder, is bigger than 0.5, then you want to add to num 1. Now it's 89.57, and then when you multiply by 100, and now I'm going to divide that by 100. And you get 89.57, which is what you're after. So the algorithm in this one is a little more challenging, I understand, but that's the goal, to challenge you a little bit. Let me know if you have questions.